Hello and welcome to my final ramble for this exam paper, May 2022, paper 1 from the department. I cannot believe that I have just gone and recorded all these videos in one day. And if you were here at the beginning of the series, you will have heard that, I was sharing that when you guys engage and when you leave messages of just like, we're getting this, we're feeling this, it really does amp me up. Recording a full series in one day is like next level amped up. I think there was an infusion of guilt that I hadn't uploaded anything in a while, but I think primarily the energy, the boost did come from just hearing from a couple of you guys that, man, these videos are doing something. So please don't hesitate to leave behind comments, leave questions. If you want me to address another question on an exam, maybe even an exam I haven't looked at yet, do let me know. These are things that I so love to do, so it wouldn't even remotely be a burden to me to re-explain something or to, make more videos just talking about whatever you want me to talk about. Anyway, question 10.3 from this paper. There are 120 passengers on board an aeroplane. Passengers have a choice between meat sandwich or a cheese sandwich, but more passengers will choose a meat sandwich. There are only 120 sandwiches available to choose from. The probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18/85. Calculate the probability that the first passenger will choose a cheese sandwich. My goodness. Okay, so I have to confess that when I was wrapping up my previous video, I accidentally caught a glimpse of the answer for this question. So I saw that they use a tree diagram. But I did not look any further than that. So yeah, anyway, now I'm just overwhelmed by all the meat and the cheese going on here and I'm hungry. It's just a disaster. Let's read again. There are 120 passengers on board an aeroplane. Passengers have a choice between a meat sandwich or a cheese sandwich, but more passengers will choose a meat sandwich. There are only 120 sandwiches available to choose from. The probability that the very first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18/85. Calculate the probability that the first passenger will choose a cheese sandwich. Okay, so in as much as, like I said, I did see that they use a tree diagram. For me, it's kind of giving two-way contingency table, maybe. I don't know, because I am confused. So let's just say this is passenger number 1. And this is passenger number 2. Okay, and this is passenger number 1 choosing meat, passenger number 1 choosing cheese, passenger number 2 choosing meat, passenger number 2 choosing cheese. Okay, there are 120 sandwiches available to choose from. So, the probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18/85. So, passenger number 1 chooses meat, second passenger chooses cheese is... Wait, so where does that go? Meat and cheese comes here. Okay. Calculate the probability that the first passenger chooses cheese. So that's this probability. Passengers have a choice between a meat sandwich or a cheese sandwich, but more passengers will choose a meat sandwich. There are only 120 sandwiches available to choose from. The probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18/85. Calculate the probability that the first passenger will choose a cheese sandwich. Wow, what is happening? So I mean, let's just say there are X meat sandwiches and 120 minus X cheese. So passenger 1 choosing meat, I don't know, I guess is X out of 120 times 120 minus X over, there would be 119 sandwiches left. Is that what we're solving? So let's see what that works out to. So that will be X times 120 minus X over 120 times 119 is equal to 18/85. Okay, then we can do some cross multiplying. So 120 times 119 times 18 is equal to 85x times 120 minus x. I am not even going to try to simplify this number. Evaluate it. 120 times 85x minus 85x squared. So this is a quadratic equation. So this will be 85x squared minus 120 times 85x plus 120 times 119 times 85. Okay, maybe it is time to work out what these numbers are. So we have 85x squared, and then, I mean, actually, there's an 85 in all of these terms, so we can firstly divide through by 85. So we've got x squared minus 120x plus 120 times 119. Okay. So now we can solve our quadratic, right? So x will be equal to minus b plus or minus b squared minus 4ac divided by 2a. Okay, so let's see what we get. Oh my, that doesn't look right. Just because the x is the number of sandwiches. How are we gonna have 6? Ooh, and it's a complex number. Oh, worse yet. So this is non-real. This answer is non-real. That's what you're telling me. Let's just double check what's going on here. So we said 85x times 120 minus x, and 120 times 119 times 18 is this side. Oh, where did I get 85? Oh my goodness. Oh, Colly Wolly, tummy. This is an 18, my girl. Right. So let's fix that up. Okay, so I'm just going to write this out for myself. A is equal to 85. B is equal to minus 120 times 85. And C is equal to 120 times 119 times 18. Right? So let's put those into memory. So 85 is my first number, minus 120 times 85 is my second number. Okay, and then lastly 120 times 119 times 18 is my third number, my third coefficient. So now I can do my quadratic formula, which is negative b, we'll start with the plus, b squared minus 4ac divided by 2a. Okay, so that gives me a nicer looking number. So therefore x is equal to 84, or I can minus over here, and that gives me 36. Nice. Okay. Right. So, okay, let me just highlight this to clarify this some more. Okay, right, so now this is where the mystic information comes in handy. More passengers will choose a meat sandwich. And it's not even that more people will choose I guess it implies that more meat sandwiches are available than cheese sandwiches. Otherwise, more passengers would not be able to choose meat sandwiches if there were less meat sandwiches than cheese sandwiches, right? So this thing is kind of a coded way of saying that there are more meat sandwiches than cheese sandwiches. In other words, x is greater than 120 minus x. So the answer can't be 36, right? Because 120 minus x in this case is going to be 120 minus 84, which is 36. And in this case, 120 minus x is 84, I'm guessing. Right, so it can't be this one, because then there'd be more cheese than meat, so it can't be. Okay, x is greater than 120 minus x, which you can also think of as 2x is greater than 120, which means x is greater than 60. Okay, so that would also immediately disqualify the 36. It's not greater than 60. So that would be, what is the answer? What is the question? Calculate the probability that the first passenger will choose a cheese sandwich. So there are 84 meat, 36 cheese. So the chances of them choosing the first passenger choosing a cheese sandwich, there's 36 of them available out of 120. So I think that is about 30%. Let's double check with Calci. Yes. So those are the odds. Let's see what the memo thinks. Wow, that was very puzzling at first. Wow. The memo says, yes, and the approach is the same. Right. So the way that they use the tree diagram is pretty much the same. So they say that, first passenger is either going to choose meat or they are going to choose cheese. And then the second passenger will either choose meat or cheese, or likewise here, right? And the chances of the first passenger choosing meat is out of 120, there are X meat sandwiches available. And there would be 120 minus X cheese sandwiches available. And we were told the probability of the first passenger choosing meat and the second one choosing cheese, and we're told that that was 18 over 85, right? So for the second passenger, there's 119 sandwiches left, of which there would be one less meat, and there would still be 120 minus X cheese, right? What we started out with, right? So over here we would have, out of the 119, we'd have one less of the meat ones, but the cheese ones would still be the same. So then the equation is exactly the same. We say this times this is equal to this, which is what we solved for. But yeah, the tree diagram I think does give a better visual of where that equation came from. Wow, okay, very, very interesting little question. Lots of reading, lots of English. But again, I do hope that this was a fruitful chat. Ended up being a very nice, elegant solve. Yeah, thank you for hanging around, and catch you next time with paper 2 of this, paper 2 of this series, the paper 2 twin of this series. Yeah, let's say that.